Hello, my name is Alizée Desrousseaux. I am a PhD student at the University of York, working with Brett Salak and Alistair Boxall. I am going to present a bit of my research on the development of socio-economic scenarios to study the future of chemical emissions. A little bit of information about the motivation behind this work. We use a massive amount of chemicals in our daily life, which lead to chemical pollution affecting the local living organism, as well as the quality of our environments. At the same time, we also are living in a rapid changing world with socio-economic, technological, and climate changes. Those changes will affect chemical consumption and therefore will affect the risk that chemicals are posing to the environment. Therefore, our research question was looking at the climate and socio-economic changes scenarios available. How can we study the risk that chemical will pose in the future? The research community is already using scenarios to study the future. You might have come across those graphs showing changes in temperature, precipitation, or sea level based on different greenhouse emission scenarios. Those scenarios, called the representative concentration pathways, the RCPs, were developed to allow all research on the future to be based on similar climate change scenarios. The RCPs are a success as they are massively used across research, but they are only one tool to study the future, and they do not account for socio-economic changes. This means that if we only use RCPs to study the future, then we ignore or we do not take into account changes in society such as economic stability, regulation, or politics. For the future of chemical usage or chemical emission, we believe that socio-economic changes are important and should be considered. The SSPs, the Shared Socio-Economic Pathways scenarios, were developed for this reason, to study the future on the socio-economic changes. They are another set of scenarios developed by the climate change community, and they describe 5 different future societies based on their capacity to adapt and mitigate to challenges. They are based on 6 main socio-economic drivers: demography, economy and lifestyle, human development, policies and institutions, technology, and last, environment and natural resources. For each SSPs, there is a society described with different assumptions for all of those drivers. You have, for instance, SSP1, that is a very sustainable and human-based society where mitigation and adaptation challenges are low. On the opposite side, you have SSP3 with low human consideration, low environmental consideration, and weak international institution. In SSP3, mitigation and adaptation challenges are high. So for each SSP, there is a diverse and detailed storyline available to use for research. The SSPs are meant to be used as baseline to study the future on the socio-economic changes. They were initially developed at a world scale, but now have been extended to different spatial scale, like Europe, or to specific sector, like agriculture. But SSPs have not been extended to the chemical sector yet. So the socio-economic changes that are forecasting to happen in the next years have not been studied on chemical emission yet. The issue with not having socio-economic scenarios and only focusing on climate change is that we are missing out on a lot of other driving factors for the chemicals, and we are limiting our understanding of future chemical pollution issue, as well as our capacity to develop adequate adaptation and mitigation strategies. Our research started from here. We wanted to extend SSPs to the chemical sector. Initially, our idea was to develop a set of basic scenarios that can be further extended to specific research questions within the chemical sector, like it has already been done for other sectors. However, we realized that to do so, we needed to select key drivers and choose one study scale that would fit and make sense for all chemicals. The nature and particularities of chemicals made that step not possible. The reason is that chemicals are all very different. Chemicals differ in physical and chemical properties. They differ in usage, in pathway in the environment, and in the way they biodegrade. The selection of key drivers that would cover all at the same time chemicals like caffeine, PFOA, antidepressants, and pesticides is not possible, as they are all very different and they are used very differently. The same thing applies for the selection of study scale. Scenarios has to be developed at one spatial scale, could be a country, a city, a land, but for chemicals, some are very persistent and can travel throughout the world, and other biodegrade fast and can only travel a small spatial area. So we could not determine a scale that would be relevant for all chemicals. So we decided to develop our own framework based on already published methodologies and to adapt it to what we wanted to do, to be able to extend SSPs to single chemical or group of chemicals sharing similar features. We developed a 4-step framework, easy to apply for scientists with no expertise in scenario development and does not necessarily require shareholders, even if it's highly recommended. The first step of this framework is to define all the characteristics of the scenario wanted. So what is the goal? Who is the targeted audience? What's the topic of the scenario? What are the temporal and spatial scale wanted? And last, the type of format. Could be text-based, could be a graph. The second step is to define the connection between the SSP drivers and the thematic focus. As I mentioned before, SSPs are based on different drivers like human development and sub-drivers like mortality, fertility, and migration. For all of those drivers, a literature review has to be conducted to gather all the possible connection between the drivers and the topic of the scenario. In this step, it is also possible to brainstorm possible extra connection, not to be limited by literature. Now that we have a large picture of what could impact our topic, we can go to the step 3, where we prioritize the drivers to focus the scenario on the key drivers only. For this step, and if it is possible, we recommend to reach to different expertise, to different experts, to gather multiple opinions and improve the full understanding of the topic. With the key driver list and the literature review, it is now possible to develop scenarios. We recommend working first on each key driver at a time before considering all the drivers to create a single storyline. The way to do it, and it will be clearer in the next slide, is to based on the literature and on the assumption made by the SSPs, is to make an assumption on how the topic could be influenced for our spatial and temporal scale. When this has been done for all drivers, we can then propose a single storyline considering all drivers at the same time. Okay, so we developed a set of scenarios following our framework to look at antidepressant emission in Europe in 2050. So first, we determined the characteristic of our scenario. We wanted to extend 3 European scenarios, SSP1, SSP4, and SSP5, to antidepressants emission in freshwater system in Europe in 2050. Our target group was scientists such as ecotoxicologists, chemists, or social scientists working on the future. We wanted to obtain qualitative storyline with the detail of each key driver influence on antidepressants emission. So we first conducted a literature review and some brainstorm activities on all SSP drivers, and we look at possible effects on antidepressants. Then we presented this review to a group of 9 experts and asked them to, based on their expertise and on the review, to determine which drivers should be considered as high priority for antidepressant emission in Europe in 2050. At the end, we had 11 drivers that were considered high priority by at least 70% of our experts. So using this list, we were then able to develop our own scenarios, and this is what we've got. This is a table showing our results. You have first the list of our 11 drivers. Then you have the assumption made for the European SSPs for each of our drivers. So we have SSP1, SSP4, and SSP5. And last, you have our own assumption for antidepressant emission with increasing and decreasing trends. We first work on each driver at a time to deduct increasing or decreasing trends for antidepressant emission. You can see that with the arrows. In these scenarios, the influence of culture and belief on antidepressants was uncertain, so this is why there are some question marks. At the end, we propose a storyline gathering all drivers and suggest if antidepressant would increase or decrease under each of our SSPs. If we want to look at the overall result of our scenarios, we believe that considering the key drivers of antidepressants emission and the described societies for European SSP1, SSP4, and SSP5, we believe that for SSP1 and SSP5, antidepressant emission would decrease because of high investment in human development and in human well-being. For SSP4, despite a high economy and high technology development, that makes that there is a low unemployment rate. The low consideration of individual in the society makes that the emission of antidepressants is actually increasing in freshwater system. To conclude about our framework, this framework allows the extension of SSPs to chemicals for the first time, but it could also be used for any research topic that cannot be assumed homogeneously. The use and development of scenarios using SSPs and RCPs should be encouraged so that we can all work under the same storyline for research on chemicals in the future and to have consistency across scale and sector. We are planning next on developing chemical emission for different spatial scales, such as Europe, or a specific context, such as European cities. This work was conducted alongside with two other PhD students from the ECORIS 2050 project, Purnima Nagesh from Utrecht University in the Netherlands, and Rudrani Gajraj from the Boku Institute in Austria, and with Casper Kok from the Wageningen University. We also wanted to thank all the experts that helped us for the development of our scenarios. Feel free to ask me any question in the comment box or during the live session. Thank you for your attention.